Hello, everyone. Welcome to the second lecture of the preview of my book, Acing the SAT on a Budget. For those of you who are just now joining, my name is Imran Aziz, and these slides and this video are meant to give you a glimpse of my book, Acing the SAT on a Budget. They are not meant to be a comprehensive substitute for the book, but they will give you some high tips that'll help you get a really high score. Just a little bit about me. On the March 13th, 2021 SAT, I scored a 1600 without the use of any tutoring or courses. I, in total, spent about $50 on old books, and then I also used some free online resources. And my book, Acing the SAT on a Budget, is currently available as a Kindle ebook for $6, and all the proceeds go towards rescue.org for helping Afghan refugees. So, this lecture and these slides are going to be focused on the math section of my book. So the math section of my book is divided into three parts. The first is common mistakes, the second is becoming more efficient, and the third is a compilation of challenge problems that I picked out. In this lecture, I'll just be going over the first two sections. So, common math mistakes. So basically what these are mistakes that you can make in spite of knowing all the content, because lots of people take the SAT who know all of the content they need. They've taken all the necessary math classes and they know all the content, but they still make these kinds of mistakes. And so in order to get a perfect score on the math, you have to be able to avoid these kinds of mistakes that you could make even if you still know all the content. So the first mistake like this is double negatives. So lots of questions involve double negatives and it's very easy to miss them, especially if there are lots of steps in solving something. If you miss it in any single step, that will result in all the subsequent steps being wrong and you will get the wrong answer. So here's an example of a double negatives question. So over here, we've got two expressions that we need to simplify. And so we see this right here, this double negative, and if you miss that, then you'll get the question wrong. And there will be lots of other questions where this is a part of a step of a multi-step process. And if you miss it in one of those steps, like I said earlier, you will get it wrong. So always make sure you're watching out for this, and always make sure you're watching for the parentheses as well, because that can change the sign of a term. Another thing that lots of people miss is scaling depending on the dimension. So a lot of geometry questions on the SAT have to do with scaled figures, and you need to make sure that you understand the difference between the scaling of each side and the scaling of the final measurement. So if I multiply the side length of each square of a square by 2, that will make the area 4 times the original, not 2 times. So it's important to remember that distinction. So an example question: if I have a right cylinder with a volume of 22 cubic centimeters, and then I make another right circular cylinder with twice the radius and half the height of this cylinder, then the area will be different. I mean, the volume will be different, but it will not be different just the same as the dimensions are. It's going to be scaled differently. So by reducing the height by half, you will be halving the volume, but by uh, multiplying the radius by 2, that's going to have a quadratic effect on it. That's going to multiply it by 4. So if you account for both of those things, multiplying by 4 and dividing by 2, we'll realize that the volume is being multiplied by 2, which would make it 2 times 22, which is 44. Another common mistake is getting the slope of a line of the vector from a dot plot, but using points that are too close. That's the mistake. And if you use points that are farther apart, then you'll minimize the relative error. So even if those points, even if when you do your calculations are a little bit off because they're so apart, that error will be smaller relatively. So here's an example of it. If you use these 2 points that are close together, the slope will look like it's 1, rise of 1 over a run of 2. So you get about 1/2 for the slope. But if you use these 2 points, which are farther apart, it's going to look more like a rise of 3 over a run of 10. And so you'll end up with 0.3, which is more accurate. Now, sometimes you might be tempted to use points that are close together because they might be closer to integers, and because they're close to integers, the calculation might be easier. But just because the calculation is easier and it's closer to integers, that doesn't mean that the error will be smaller. The relative error is a lot larger because those points are so close together. So always be looking for points that are farther apart that you can use to find the slope, because then the error will be smaller. So a way that you can avoid a lot of mistakes is by always factoring. If you have an expression like this where you have these two you have variables in the denominators, it's very natural to cross multiply, which will result in quadratic terms for both the numerator and the denominator, which you'll then have to factor and cancel to get this answer. However, if you notice that this expression, 4a plus 8, is equal to 4 times a plus 2, then you can rewrite the equation as this. You can get this equation, which is a lot easier to manipulate than this final answer. So with graphs, you should always look at the origin. You should always look at the intersection of the x-axis and the y-axis, or the bottom left of the graph, to make sure you know what it is, because it will not always be 0, 0. If you have a height versus age plot for teenagers, the origin that you see might be age 13 and height 4. But if you just assume that it's 0, 0 without actually looking at it, you may forget to add 4.0 for the intercept. Okay, so now becoming more efficient in math. So this is beyond just making mistakes. This is how to actually save time on the easy stuff and the hard stuff so that you have more time to go over. So a way you can become more efficient in math is by using the number 100 for percentage problems. So sometimes you'll be given a question where you're only given percentages, you're not given an actual number. So an example of this is this example question that I have right here. So if it says 40% of the school takes the bus and 30% of those who do not take the bus walk home, and it asks you what percent of the school neither takes the bus nor walks home, you don't have an actual number given to you. So you can just use a number 100. And since that number is really easy to manipulate, this question will become a lot easier. Also, if you always look for things to cancel, you will be able to solve questions much faster. So in this example expression right here, you can factor the numerator and see what factor appears in both. So in this case, it's x plus 3. So you can cancel that out to simplify. Here we factor the numerator, but in other problems, you may need to factor the denominator, or you may need to factor both. Okay, so another way to become more efficient at solving questions, is specifically for linear equations, is to always kind of look at what the most efficient approach is, whether it's substitution or elimination, or sometimes it's just adding all of the equations. If one of the equations looks like you can cancel the other out using elimination, then use that. If one of the questions has an isolated variable or is very close to having an isolated variable, then use that, use substitution. Usually, whichever method minimizes the manipulation of equations is the best, because the more manipulation you have to do means the more steps there are, and the more steps means there's more opportunity for errors. Usually, you will see a clear choice of which method to use. Usually, when you see the systems of equations, you'll see which method, whether it's substitution or elimination or adding all three of them. Usually, you'll see which one is the most efficient. So here's an example where you can add up all three of the equations to get an isolated variable. So if you look at this and you're completely confused and you have no idea what to do, then just add all three of them up. For these optimization problems, which is basically where you want to maximize or minimize something, on multiple choice, sometimes you can just try each possibility. This is a lot easier on the calculator section because it's a lot easier to plug in numbers and do these calculations. If it's not multiple choice, you can try to brute force all the values and see where it peaks out, where it maximizes or minimizes. Or you can just formulate it as a quadratic, and then you would know that the vertex, which is either the maximum or the minimum of the function, is going to be at x equals negative b over 2a. And really, it just depends on how complex the function is, which ones of these you want to use. If it is extremely complicated and you feel like you're not going to be able to, find the quadratic equation and then plug in the vertex, then you should just brute force it. But if you feel like that's going to take too long and you think it'd be simple enough to work with the quadratic, then do that. So this is an example of an optimization question. So we've got a price, and then we've got the amount that is sold at that price. And then as the price increases, the number of meals sold decreases by a certain number. So in order to find the price that results at the greatest sales, we need to see which combination of price and quantity results in the greatest total revenue. And so you can look at this and you can try to brute force the values, or you can try to write it as a function and then solve it like that, whichever way you think would be most efficient. Okay, so for roots and coefficients. So if you know how the roots of a quadratic relate to the standard form coefficients, you'll be able to find them much easier. It's very easy to make this mistake with negatives, so be sure that you know exactly where the negative signs are and which parts of the expression they apply to. So for an example, we have to find the product of the two solutions to this equation. You could just get the roots using the quadratic formula, but those involved really difficult square roots which cancel out when you multiply them. So it'd be a lot easier if you just rewrite the equation and then rewrite it in standard form, and then you can just see that since the final term is negative 5 over 8, that AB is negative 5 over 8. because A and B are the solutions. Okay, so for some geometry, for interior angles for regular polygons, you should remember this equation, that 360 plus x times n equals n times 180, where x is the interior angle and n is the number of sides. And basically the reasoning behind this is because you can add up the number of triangles formed by the sides in an interior point. So over here we've got a 9-sided polygon, and this basically creates 9 different triangles, right? Because you got the sides and we've got this central point. And so because the sum of all the angles of a triangle is 180, the sum of all these interior angles is going to be 180 times the number of triangles minus 360 to get rid of this circle here. So if I do 180 times n, which is the number of sides, minus 360, then I'll get the sum of all of these angles here. And so then I can just divide that by however many points there are to find out what each individual angle is. And that's how you would solve this question. Also, knowing some basic trigonometry facts can make things go a lot faster. If you memorize that sine of x is equal to cosine of 90 minus x, you'll be able to do some questions a lot quicker, and sometimes that will actually be the only way you can do a question. So, and not even just a matter of going faster. It's just a matter of getting the question right in the first place. You should also understand the sign of cosine and sine for x in the 4 quadrants. So whether it's positive or negative, depending on whether x is in between 0 and 90, 90 and 180, 180 and 270, or 270 and 360. Just understanding the sign of these trig functions depending on what quadrant they're in. Also, you should remember the Pythagorean theorem as it relates to sine and cosine. Remember, sine squared of x plus cosine squared of x equals 1. Knowing that and being able to recognize where you can use it, that can save you lots of time. And again, it will sometimes be the only way of solving an equation. So here we've got a straight trig question. We know sine of x is something. We need to know what cosine of 90 minus x is. So we know that sine of x is equal to cosine of 90 minus x. So actually, the answer to this is just 4/5. So this is an example of where knowing that rule is the only way of solving this question. Okay, thanks for watching. If you haven't, please be sure to check out my previous video where I go over the introduction and outline of my book. And I will be making another video soon about the rest of the sections of my book. So thanks for watching.